Okay, let's take a look at this time value of money problem that deals with saving for retirement. You see the problem in front of you. You're 24 years old and you decide to start saving for your retirement. You plan to save $6,000 at the end of each year, so the first deposit will be 1 year from now, and you'll make the last deposit when you retire at age 66. Suppose you earn 10% per year on your retirement savings. Okay, and there's Part A and Part B. Part A says how much will you have saved for retirement, and Part B says how much will you save if instead you wait until age 37 to start saving. Okay, now there's a few ways you can solve this. Let's say you wanted to do this with a calculation. Put this on the screen here, maybe slide down a little bit. Okay, now if you wanted to solve this with the calculations, using either a calculator or doing it by hand, I think you'd have to use a calculator on this one. This is how you'd approach it. First, you have to understand what the timeline looks like, right? You're going to make $6,000 a year payments starting 1 year from now, and that's going to go on for 42 years, which was, age 66 less your current age. Okay? And what you need to do is calculate the present value of all the savings using this formula here. And when you plug all that in, you'll get $58,904. Now you can calculate the future value of that $58,000 taken for 42 years at 10%. Okay, so 10% is our interest rate, 42 is the number of periods. We calculated the present value using an annuity of $6,000. And you could solve it this way, but of course I wouldn't do it this way. I'll show you an easier way using Excel. Okay, and here's Part B. And Part B is essentially the exact same problem, only instead of using 42 periods, right, 42 periods on the timeline, you're starting at age 37, so there's only 29 periods. So anywhere there was a 42, you're going to post a 29. All right, so you could pause this and work this to make sure you come up with these numbers if you like, but let me show you how you could solve it with a financial calculator or with Excel. Okay, first let's look at a financial calculator. If you're using a financial calculator, whether it's a physical one or an online calculator, you'd put in these factors into your calculator. The number of periods, 42, which is 42 years. The rate, 10%. We're making annual payments, so 10% is the right amount. The payment we would enter as negative because that's a cash outflow. And remember that Excel and calculators treat outflows as negative numbers, cash inflows as positive numbers. You could leave future value at 0 or just not enter it, and then solve for present value. That would give you the $58,904, and that would calculate the present value of those 6,000 payments. Okay? And then if you wanted to use that information and solve it for the future value, you'd put in 42, 10%, the 58,904 is the negative. In other words, we're now giving up a present value of $58,904.38. And in exchange, we'll solve for a future value of $3,225,822. Okay? And you could solve it that way. They also show you that you could solve this in Excel this way. And they're still assuming that you're going to solve for present value first and then determine the future value in 2 steps. Now, you really don't have to do that in 2 steps. I'm not exactly sure why they're presenting it this way. If I were to solve this with a calculator, I could solve this directly for future value by putting in the payments, put it in here, not solve for present value, and hit future value. Or in Excel, that formula right there can be replaced with something different. Let me show you. Move this all out of the way now. All right. Now here's how I would solve Part A directly, and I wouldn't have to worry about solving present value at all. The number of periods is 42. How did I come up with that? Age of retirement less your current age. 66 minus 22 is 42. They gave us 10% as the rate. Let me slide up so you can see all this, right? The payment we enter is $6,000, and then we solve for present value. And here's how you do it. Here, I'll do this from scratch. Equal FV, hit the left parenthesis, then I come up here to this insert function, and I get this pop-up window. And the pop-up window is very useful. It leaves an audit trail. So what's the rate? It's given right there. Number of periods, given right there in cell C11. The payment is given right there. And when I'm done, I've got the future value, 3225822, which matched our answers that we solved earlier. Now, to solve for B, let's just copy all of this. And the only difference is now you're waiting until age 37. So we're going to retire at 66. This becomes 37. So the number of periods, it's only going to go 29 periods, and we see that becomes 89,786. Did I say that correctly? It's 891,786. And that matches what we did earlier. If I put this up here, you see there's the 891,786. Okay, so there's a number of ways you can solve this, but for me, just setting it up in Excel and using future value or present value if you want to solve a present value problem, to me is the easiest. Others may prefer the formula, others may prefer to use a financial calculator. All of those ways work.